Warm greetings to everyone. It gives me immense pleasure to meet you all in this webinar of electric vehicle. Before we start the program, let us all rise for the Tamil Thai Valthu.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டனிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Technology is best when it brings people together. According to a new report by Bloomerang New Energy Finance, 58% of the global passenger vehicle sales in 2040 will come from electric vehicles. So in this webinar, we are trying to bring in industry experts who will be speaking about electric vehicle and how it is going to be applied and how humanity is going to change because of that. So let me introduce today's first keynote speaker, Srimati EVA JAMES. She comes with close to 3 decades of experience in information technologies spanning across banking, finance, insurance, and automobile industries. She is currently the Vice President of Renault Nissan Information Systems Infrastructure at Renault Nissan Techno Center in India and is spearheading the Connected Car program. In her last assignment, she worked as the Technology Director, Bank of New York Mellon Technology. She has widely traveled and played diverse roles during her career. She graduated in computer science from Women Christian College in Chennai. She has always championed diversity causes and has been instrumental in setting up of the Women's Network at Renault Nissan India. She actively works with universities focusing on empowerment of girl students. With this, it gives me great pleasure to have you with us in the session, ma'am. The session is yours, ma'am.
Thank you, Joshua, for the introductions. It's lovely to connect with all you people on this Sunday evening via the virtual platform. I truly applaud Tatti for championing such interesting, relevant sessions while we are all locked down at our homes, bringing this content to the luxury of our homes. Today, we have a very relevant topic, electric vehicles. A topic which is very close to me because as Joshua was mentioning, I work for Renault Nissan, and this is one of our core strategies to bring in EVs to the market. And so I'm excited because we talk about this every single day at workplace. This is part of our core strategy, as I mentioned. Before we get into the electric vehicles part of it, let's take a few moments to look at what's moving the auto industry. Technology and new business models are bringing in disruptive changes. When I say disruptive, positively disrupting the industry, right? The concept of car ownership has got a new dimension with shared mobility. The professionally managed fleets will reduce the cost of mobility through more efficient use of expensive mobile assets. We are all beneficiaries. The Ola and the Ubers are integral part of our lives today. So this is not something which is happening in the Western world. The shared mobility is a reality in India as well. Coming to autonomous driving, when this becomes a reality, we will all become permanent backseat drivers. The development of these vehicles with no human intervention, heavily relies on the application of artificial intelligence and machine learning algorithms. A lot of OEMs are investing much of their energies in this space because this is expected to make driving more accessible, cheaper, safer, and easier in the days to come. Connected car program, a program which I'm personally very involved at Renault Nissan, talks about communication, has two flavors. One, the communication between the cars and the external systems, and the communication between the vehicle occupants and the outside world. There are umpteen number of use cases which we are using today, which we are applying and building. Very, very simple things like cars which can self-correct. Like for example, if the tire pressure of the car is hitting to a threshold, then today the car is intelligent enough to book an appointment with your most preferred car service provider. Similarly, with geofencing, families are able to look at where the children are going or moving around in the city, young drivers. We have had use cases where buddies who are on a road trip can share the GPS maps to colleagues and other friends so that they're all looking at the same maps. So the number of use cases that the connected car brings to us is going to completely enhance the end user experience. The car of the future will really become a third place after our home and our workplace, right? So this is something which is already there. In fact, many of our Renault and Nissan cars have very advanced features of connected cars enabled on them. And then if you come to the topic of the day, towards a greener earth, the electric vehicles. How does it look? It took 5 years to sell the first million electric cars. And in 2018, it took about 6 months. And then came 2019, and in 1 year, 2.1 million electric cars were sold globally. That's a huge jump, and this is a jump which just tells the relevance of this car in the world, the importance that the OEMs are giving to building and changing the focus from traditional gasoline and diesel cars to the electric cars, and the thrust which the governments and the authorities are bringing to make these cars more viable to the people, right? So if you look at how the world is using this space, the electric car space, it's very interesting to see that the Nordic region leads the electric car adoption, right? Statistics which have come at the end of the first half of the year say pure electric cars made up almost half the car sales in Norway, in a world record, as battery-powered vehicles suffer less than fossil fuel rivals during the economic downturn caused by the COVID-19. France and UK already have plans to stop all the production of petrol and diesel cars by 2040. Denmark and Sweden have more electric car charging docks than petrol booths, and they have released more huge exemptions for vehicle taxes for electric cars. Not just the government and the authorities, car makers, the OEMs are coming together. Renault, Nissan, and big players like Volkswagen are pledging on the table billions of dollars to invest in zero emission vehicles by 2030 and beyond. So if you will see, the world is really gearing up for a motorway which is only driven by electric cars, right? So on this note, before I go further into the Indian market, I have to talk about some of our flagship products, right? Today, 1 in every car, every electric car that is driven in Europe is a Renault car. And I work for Renault and Nissan, which is an alliance together. And not just 1 in 4 being a Renault Zoe car. There's a huge, very interesting lineup of electric vehicles which Renault brings to the table, namely the Master, which is a van, the Kangoo, which is a semi SUV, we have Zoe, and we have Twizy, which is the fully battery electric vehicle. And not just on the Renault front, if you look at Nissan, Nissan's Leaf, which is our flagship electric vehicle from the Nissan world, is the world's all-time best-selling highway-capable all-electric car. This is the world's most sold electric car in 2019. Very proud to say that this comes from our shop. And not just this, we have a huge lineup of electric cars which are very popular. Mitsubishi, which is part of an our alliance has Outlander, which is an SUV. We have Ariya, which will actually soon hit the Indian market as well. And of course, the Leaf. So these are some of the offerings from the Nissan, Renault and Mitsubishi Alliance family, which are very popular. We have been in the business of building and selling electric cars for more than a decade now. There is a continuous focus, as I said, on three elements at the alliance. One is the electric cars, second is autonomous driving, and the third is the connected vehicles. So today, if we are talking of the connected vehicles, let's see what's happening in the Indian context, right? India, being the world's fastest and the largest growing economy, is facing a plethora of risks associated with rapid urbanization. The private ownership of cars have skyrocketed in the past 2 decades, leading to a huge increase in air pollution level, congestion, and a huge dependence on fossil fuels. A recent study has estimated, a study by WHO, which was published in January of this year, said that 74,000 premature deaths have been attributed to air pollution from transportation tailpipe emissions in India. As the number of motor vehicles on the roads double every 8 to 10 years, the CO2 emissions are bound to get worse. Right? We really don't want these fancy titles being Delhi being India's asthma capital or the 15 countries in the world's most polluted cities coming from India. These are not something that we want to be proud of. We've all heard of all these hardships that the Delhi citizens had to go through with the smog. The pictures that you see are definitely not pictures where people are wearing masks because of COVID-19. These are pictures taken much earlier. They were wearing these masks to protect themselves from the pollution and the smog. Schools were shut down. There were inconvenience to commuters because they were alternate day, odd numbered cars on one day and even numbered cars on another day. So we saw a plethora of environmental issues coming because of pollution. And without a doubt, the primary source for all this pollution is vehicles, right? And we know that. Vehicles are one of the contributors to air pollution, and we are at a point of threshold where vehicular emissions have to be monitored and controlled. And recognizing this, the Indian government and the auto OEMs in India have been continuously working towards defining guidelines for optimal fuel economy and for regulations for emissions from the cars on the streets, right? And towards this, we had the BS4, and today every company is trying hard to be compliant to BS6, and every OEM, in fact, is almost distracted from introducing new models to become BS6 compliant. So that is the stress that this has put on the existing OEMs in India. I can say this for sure because from Renault and Nissan perspective as well, the BS6 compliance has been on the forefront of all the initiatives that we're doing in India. And to be compliant, the OEMs are putting a lot of efforts, right? Many solutions, many technology-driven solutions like the three-way catalytic converters, the advanced calibration techniques, the gasoline particulate filters, all these initiatives to control emissions, right? And if you will see this diagram, this is not controlled at 100%. We still have a significant amount of emissions that are coming out, but to get to this extent, the OEMs are paying a big price, right? This is almost putting a risk on their existence, right? In fact, there are many OEMs who are even wondering whether BS6 compliant makes sense from a financial perspective, because the margins are very slim, and the fines that the OEMs have to pay if they are not compliant to BS6 and if they don't have the regulations adhered to, it's going to make their margins even slimmer, right? And this is having a huge impact on the diesel and commercial vehicles, and diesel and commercial vehicles will see a drastic cost increase if they have to be compliant to BS6, which means that customers will pay more as well, right? So if this being the situation, India looks, there's another aspect to it, right? The fuel, the fossil fuels, the source of all of this is is imported, right? India exports enormous amount of crude oil, which is the fundamental raw material for all our petrol and gasoline. And India has tall aims to cut its oil import bill by roughly half by 2030. This is on the Indian national agenda. So the government has time and again has been very vocal about its intent to move all its vehicles to run on electricity by 2030 and beyond. It might take longer, but at least the intent is very, very clear. And not just the Indian government and the authorities and the experts are saying that. In the last few months, while the world is battling the COVID-19 pandemic, a study by the Harvard University found a striking association between long-term exposure to harmful fine particulate matter and COVID-19 mortality, right? And one of the primary causes for fine particulate matter pollution is the combustion from gasoline and diesel car engines. So the need is really urgent, and going electric is the only way forward for India. And if you look at the statistics, we saw some of the world statistics, but if you look at the Indian statistics, at present, the EV market penetration is just about 1% of the total vehicle sales in India. And in that 1%, 95% are electric two-wheelers. So you can understand how low the market cap for electric cars in India is. Right, the National Mission for Electric Mobility, a program which was launched by the Government of India, lays the vision and provides the roadmap for achieving significant penetration of efficient and environmental friendly electric vehicles. Right, so this is not just the government. As I said, all OEMs are coming together to make sure that this vision, this intent of Government of India is becoming a reality. And so as you said, I speak on behalf of Renault, Nissan, but every single OEM is focusing on a good lineup of electric cars, is partnering, is investing on research and development to make sure that the country has a good infrastructure. The end users have it's viable for the end users to buy electric cars. It's feasible from the electricity perspective. So all the elements of it is studied by this NMEM grant plan, and the government is very actively working on this. So very clear, we have to go electric. There's absolutely no two doubts about it. So if that is being the case, so maybe we will spend some time to understand what this electric car is all about, because many of us probably have not seen one or not been in one. So it's probably interesting to spend some time to understand what an electric car is all about. So we are very familiar with the combustion engine, the ICEs as they call it. It runs on petrol or diesel, and in the recent past we had the gas engines, not so popular, but we still have them around. But petrol and diesel is what drives the combustion engines. We are very familiar with them. But when you talk of a battery electric vehicle, BEVs as they are calling it, in its simplest form, in a BEV, instead of a fuel tank, we have an onboard battery that gets charged through an electric supply, and then it stores and uses the energy to power an electric motor and sets the wheel in motion. So this is probably the simplistic definition someone can give for a BEV. It means that cars have no need for a clutch and a gearbox or an exhaust pipe for that matter, and it makes the ride much smoother and even much quieter. Right, the propulsion is basically exclusively on the electrical energy stored in the high voltage batteries. There is a lot of challenges that when the first battery electric vehicles were launched, there were a lot of challenges when the entire dependency was on batteries, and that is when the hybrid electric vehicles came into existence, right? And what does the hybrid vehicle do? The hybrids combine a gasoline or a diesel engine with an electric motor and a large rechargeable battery. So it brings in the best of gasoline and diesel vehicles along with the power of a battery electric vehicle. These are the hybrid cars, right? The degree of electrification depends on the size and characteristics of the batteries and the electric machines. If you look at the players on the battery electric vehicle space, we have Tesla, we have our Renault Twizy. These are some of the popular pure BEVs. But when you look at the hybrid cars, Toyota leads the pack. Toyota has some of the most interesting lineup of the HEVs, as they call it, whereas the Leaf, the Twizy, and the Tesla are all BEVs. It's interesting because I was in another program where we presented the BEVs and the electric cars, and a very interesting insight came there. The electric motors have an instant torque right from the first RPM, unlike the petrol or the diesel engines, where the engines have to rev up to a few thousand RPM for that matter, and then you get the surge or the punch. For motorsport lovers in this group, you can't ask for anything better. Acceleration is as fast as a Porsche Boxster, the sports car. So these cars score extremely high when it comes to acceleration. Because of the few movable parts, the maintenance costs are lower than the regular petrol or the diesel cars, and they make much less noise. They are very quieter. It's a double-edged sword. The quieter cars are welcomed by many. In fact, one of the occasions when I happened to ride a Nissan Leaf while I was traveling abroad, you don't even feel the car moving. Right? It's that silent. And even when you accelerate it, you brake, nothing, I mean, there's absolutely zero noise. So as I said, it's a double-edged sword. Sometimes when the car is running in such a silent mode, there are people who are almost raising their hands and saying that's not safe for the pedestrians and fellow drivers. A car has to make a minimal sound. In fact, now there are new regulations which are coming to have some sound generated even by the electric cars. Imagine a country like India. I mean, in the West, people don't use horns so insensitively as in India, so which means the noise of the car probably alerts pedestrians here and there. But in India, this is something which we have to really think about, whether such silent cars would be welcomed by our society, right? So this is the context of cars, the electric cars, the battery electric vehicles, and the hybrid electric vehicles that we talk about. So here I have a very small illustration, an illustration which talks about how the combination of electric motors and the electricity generators, the batteries and the engines work together when the car is in motion, a very small simulation. So if you will see, when you start driving at a constant speed, the car only uses the motor. The electricity from the battery drives the motor, which reaches this full potential instantly. As I said, the torque is instant as soon as the motor starts running, the electric motor. But when imagine a scenario when we are going a small uphill and there is a higher acceleration. Here, in addition to normal driving, the battery supplies electricity to drive the motor, enhancing the driving power, right? So this is how hybrid vehicles use a combination of the ICE and the electric motor to do higher acceleration in higher altitudes. And when you're deaccelerating or when you're braking, this is called actually regenerative braking in the electric vehicle world. The motor is activated as a generator to convert the moving vehicle's energy into electricity and charge the battery. So the car, as it is driving, has the potential to recharge its battery, right? And then when you're back to the normal mode, there's rationalization between all the three components. And when you are stopping, the engine automatically cuts out. So there's no idling. Thereby, the CO2 emissions, even during the idling in a hybrid vehicle, is absolutely near minimal. So this is a very simple illustration of how the combination of the battery operated electric motor and the electricity generation happens inside a hybrid car. While all of this looks good, what are the challenges for a country like India when it comes to adopting electric vehicles, right? The challenges are quite significant. The first or the biggest concern for most of us would be the range of a battery. It could be anything between, say, 200 to 300 or 400 kilometers. But what if I'm touring? If I'm driving from Chennai to Hyderabad, say a distance of 650 odd kilometers, I cannot sit for 4-5 hours waiting for the battery to get recharged if I'm driving a BEV, right? So this is a concern which genuinely people have, and this is directly linked to the charging infrastructure in the country. While conventional vehicles have because today we are very confident that when you're doing a road trip, you have adequate number of fuel refueling stations, the petrol stations and the diesel stations. The same cannot be said of electric charging station in India, at least today. In fact, there was one statistics which said that today in India we have about 650 charging stations. At the same time, China has about 450,000 charging stations across the country. So that is how ready China is today when it comes to EV adoption, and how far away we are when it comes to charging infrastructure for the electric cars. So this is one of the biggest challenges. The next is on the battery itself, right, which is the core component of the electric car. There are three parts to battery production: the battery packing, the battery pack development, as they call it, the cell manufacturing, and the third is the raw material, the lithium, the cobalt, manganese, or nickel. There are varieties of raw materials that are used in the batteries that are used in the cars. Today, India heavily relies on China for all its needs. And this is also one of the reasons why EVs are priced more than the regular cars, right? The key concern here is the pricing, right? And the dependency on, especially on China for making these components. So if India has to completely shift gears from standard cars, the petrol and the diesel cars, to the electric cars, then a lot of people in the auto sector are going to lose their employments. So if traditional internal combustion engines based vehicle is going away, we will have a huge crisis with many losing jobs. So the only way we will continue to have jobs and keep this business running is to start making every subsystem of the electric vehicles in India. We have to beat China both on the performance and on the price. Right. So many OEMs are, that's why I said, are investing on research and development in this space. At Renault Nissan, we have a huge partnership with IIT Madras for the electric vehicle research and development. We have made some very interesting progress in the lithium battery design and packaging. In fact, we have a few patents to our credit. And as I said, unless there is investment on this end, there is support and a lot of subsidies and rebates from the government to research and develop this front, it's going to be a very expensive proposition for users to buy electric cars in India and to bring state-of-the-art technologies for our Indian population. Then Indians are very famously value conscious. Why do I say that? Even today, when you go out to buy cars, the reason why people prefer diesel cars are they are most cost effective compared to petrol cars. An EV car costs at least 1.5 to 2.5x times its ICE equivalent. So the value, the pricing of the EV is also something which is not very compelling for the average Indian user to buy an EV car today. Last but very importantly is the electricity supply in parts of the country. The grid infrastructure today sometimes is even inadequate to meet our basic demands as for the general population, right? So now you switch and you say if India has to supply electricity for all the electric vehicles. So there has to be a completely different orientation to electricity generation in India. Again, the power source is coal. India generates a majority, about 65% of its energy demand through coal. And then this by itself can become a pollution deterrent, right? And a variable in the pollution element, which is not something that India looks forward to. So we have to really look at alternate sources of electricity supply and make sure that this is something which gets the maximum attention from the government of India to ensure that electric vehicles have the highest amount of sponsorship. Today, many industry partners like EV Motors, Magneta Power, Alta Grid, ABB are coming forward to build charging infrastructure in partnership with the government of India. So these are some of our partners with whom we work very effectively. In fact, recently in one of the podcasts, I heard that one of the senior executives at Maruti saying that there is no way an average Indian can charge the vehicle, because today they don't even have their own dedicated parking spaces. So if in the US and in the western parts of the world and in Europe, pretty much people are able to charge their cars just the way we would charge our mobile phones. They would come home in the evening, plug in their car to their sockets, and then the car gets charged overnight. So today in India, given our limited availability of parking slots and at homes and for large apartment complexes, we have to really rethink this entire landscape as to how individuals would charge their cars. So these are all the challenges that are lying ahead of us, and unless the government and the OEMs together look at these challenges and have a very clear strategy, this is going to be a big adoption disabler for us in the coming years. While I talk about these challenges, we also have to admit that the same space is also seeing a plethora of innovations, right? A solar powered electric car that runs without the need for charging may sound impossible today, but that's exactly what OEMs like Toyota are experimenting, right? By pairing together the best solar panels in the market with the most efficient batteries available, the hope is to have a car that will run forever without the need to get charged through solar, of course, being enabled by the solar power itself, right? The other concept which is fast picking up today is really called the fast charging, using technologies wherein 80% of the battery can be charged in less than 15 minutes. So this is already being tested, piloted in many countries, and we have some cars which actually have the fast charging features. And in fact, I even heard that some of the cars that Honda is bringing to India will have batteries which have this feature. The last is the battery improvisations, right? With the trend of lithium-ion battery cathodes being improved continuously, the cost of batteries is significantly coming down. As I said, in a battery electric vehicle, the batteries and the electric motors is what is hiking up the prices. So the focus of the battery and bringing it at a cost-effective price is something which all the OEMs are focusing on, and this has seen a big positive trajectory in the recent past. Battery prices alone have decreased 80% since 2010, with the hopes of dropping another 45% in the next few years. So it's not very grim. People are continuously looking at how can we improve and innovate in the electric car space so that this can be made readily available, can be afforded by everyone, and can be seen as a most sought after vehicle on the streets, right? On that note, there's a lot to look out for in the coming years. I recently read that there are 16 new cars, electric cars, which we can look out for in India, which includes our Nissan Leaf and Renault's Kwid electric in the small car segment. So if successful, the shift to electric vehicles could potentially help India save about $300 billion, which is about 20 lakh crores in oil exports and nearly 1 gigaton of carbon dioxide emissions by 2030. Yes, India needs to be flooded by electric cars in the coming years. And with the right kind of support, this can become a reality. Renault has, as I said, a tall plan. Our future plan for the next decade is called Drive the Future Plan. And 12 new models, all electric cars, are part of our product pipeline, as in the case of Nissan, which has got about 8 cars in the pipeline. Not only introducing electric cars, using the connected car platform, they are connecting the electric cars and the connected car platform, so where users can obtain charging information in real time or control operations from a distance with their smartphones to get to the nearest charging station. So they are making it as appealing as it can to the car buyers and the fleet users. So electric vehicles are the future of motoring. I would like to end my session with this quote by Elon Musk, the CEO of Tesla, who said, "We will not stop until every car on the road is electric." So on that note, thank you very much. And I was very happy to share these insights with the group and also share with you some of the cars that are in the pipeline in the Renault, Nissan, Mitsubishi family in the electric car space. And one day we will all be driving electric cars, and we will make the place greener and healthier for our future generations. So on that note, thank you very much, Joshua and Tatti team, for giving me this opportunity. And if you have any
Thank you very much,
questions,
ma'am.
I would be more than
Yeah,
happy.
there are a couple of quick, couple of questions from our participants. Shall we go ahead, ma'am?
Yes, please.
Uh, the price of electric vehicles is quite high when compared to a normal car. Do you think this will change in the near future?
Yes,
And
one,
another question by the
yes,
same participant: um, How safe are how safe is electric vehicles?
okay. First question, I did say the electric cars today are at least 1.5 to 2.5 times expensive than the regular petrol and the diesel cars. And there is a lot of, one primarily because in India at least, it is because many of the parts are imported. The tax levies are expensive, the batteries are very expensive, and the research that is going into the space to build them locally, to build cost-effective batteries is what is getting the maximum focus. The cost of batteries used in electric vehicles have already been dipped by 85%. And with all of this, as I said, unless the prices are slashed, India is not going to be surged with electric cars. So I foresee a huge decline of electric price vehicles in the coming years, so that the adoption is increasing. The government, as a part of this national mobility plan, is already studying the space, and we will see the prices coming down. The second is on the electric cars. Yes, there were few accidents, and those were when the cars went up in flames. We've had some cases that were reported in some of the electric vehicles. So this is something which we have acknowledged in the past, that cars have been prone to this. But this is not unique. We have also seen this in electric, in petrol and diesel cars. But this aspect of it, the battery which can go up in flames, is also being studied. So that is why the amount of research and R&D initiatives in the battery life cycle management, as we call it, is absolutely important. While we say it's a zero maintenance car, the amount of time it takes to build the battery and design a battery is huge, right? And that is the only component which is prone to such accidents, and that gets maximum attention. So this, all the research and R&D is focused on building safer batteries.
Thank you, ma'am. Next question, ma'am. Do you think retrofitting uh, for a normal car, whether normal car can be retrofitted with electric engines, and is it possible, ma'am?
This is something which we threw as a challenge for at Renault Nissan, when, as I said, the hybrid cars are running the battery operated component electric motor alongside the standard ICEs, and we have not seen much success. So it is not that you take a car and you can convert into a hybrid. So the entire engine positioning, the powertrain components, everything had to be redone when it had to be made into a hybrid car, right? So as we say, again, people are studying it, so that the cost of conversion, the cost of production of such cars is also coming down. But as we speak, to my knowledge, it is not that today by fitting a gas engine at the back of your car, you're able to run it on gas. So it is not like that. People have not seen success in that front. But this is something, again, people are really studying hard to see if a conversion or an upgrade is possible. To my knowledge, it's not there.
One last question, ma'am. Is your organization planning to build any electric vehicle production plant to start? Is it already there, or will you start electric vehicle production in India, ma'am?
We do have the, as I said, the Quid Electric, which will come out. Again, this year has been a bad year for the auto sector in India. So a lot of delays. The production has been shut down for many months. So this is not just Renault, Nissan. Every one of them have had to take the beating because of the pandemic situation. The Quid electric vehicle, which will hit the market, will be completely built in India. So the plant in Oragadam, the Renault Nissan plant in Oragadam in Chennai, is fully equipped to build electric cars. In fact, we already build a lot of electric car components which are exported. But for the Indian market, the car will be built in India, absolutely.
Ma'am, on behalf of our institutions and all the participants, I would like to thank you and sincere gratitude to you for spending your valuable time with us this evening, ma'am. Thank you very much, ma'am.
Thank you all. It was an absolute pleasure.
It now gives me immense pleasure to introduce to you the next speaker of today, Mohammad Ashik Rahman, a CEO, engineer, and inventor. He's graduated, he's done his doctorate, and is pursuing his PhD, second PhD in Bharathidasan University in the field of consumer behavior and marketing research. He has also done his master's in marketing. He is the founder and CEO of Propeller Technologies R&D Private Limited, co-founder of Zafir Robots, co-founder and branding head of Dr. Fruits, brand ambassador of science and technology of Wind Wings of Fire Social Trust. He has many achievements under his belt. He's an amateur radio license holder, a completed project titled Air Drone Soldier at DRDO. He's a knowledge partner for many institutions. He research in formulation of kit technopreneurs, and he is planning to file 2 patents, and it is under pipeline. It gives me great pleasure to have you with us, sir. The session is yours.
Yeah. So is my voice audible?
Yes.
Yeah. Thank you so much for inviting me as one of the person for in this beautiful session. And yeah, as you mentioned that we are doing so many things in robotics. So we are from the company called Zafir. So we all talk about different skills and other things which is in EV vehicles. Okay, so I'm the person I can able to easily address that how the EV vehicles and the robotics can be collaborated in the upcoming days. Okay, because everywhere now the EV vehicles are completely started ruling the roads. Okay, how it is not only started ruling the roads, it's also started going to rule the air, the space, and the agriculture, crops, land, also everything. Okay, so compare from the EV vehicles. So the collaboration of the EV vehicles and the robotics, it's going to be a huge market. It is going to be a bigger, very big. I mean, it makes a very big effort in the society and the environment. So, so we developed so many robots in the time of COVID situations. We came from the name of Zafir robots. So Zafir robots we developed for hospital. I mean the hospital, the patient service and other essentials to deliver. And we developed another robot is called as Zafi Clean. That is for cleaning the hospital interior. And there is Zafi Sterilize. Zafi Sterilize, which is for sterilizing the office zones and the commercial zones, even from the college, schools, hospitals, and shopping malls. And there is another robot which is we developed for the particular thing called Zafi Rescuer stretcher. The stretcher which can helpful to burying the departed soul by COVID. And we had another recent robot, another product which is called as Zafira. So Zafira is a robot, is a highly intelligent robot. It can identify whether people, whether they're wearing the mask or not, and the people temperature and how many people are getting into the showrooms and malls. So those robots are into the market now. So these are our products which is presently in various part of the market. So when we see growth of robotics particularly in Indian market, not only Indian market, worldwide the robotics is getting more popularized, and many people are into the research of robotics. And there is too many companies are into the collaboration of robotics and the electric vehicles. Even from our company, Zafir Robots and MAuto Electric Vehicles, we both are collaborated to how we can come up with a robotized electric vehicle, electric autos. So very soon we are working on it. Very soon we will come up with very beautiful products to the market. And the electric vehicle, it is going to be play, as I said earlier, it is going to be a very big play a very big part in the agriculture, forest raising and robotics kind of. It is EV vehicle which is can attached with all the robotic setups and all. When we saw particularly in the robotics market, earlier the robotics market is completely different. When we want to learn about the robotics, or if you want to touch about the R&D and all, it will be a huge pricing. Everything will be very much expensive. So now there is too many parts which we easily able to buy. We can say it as UGVs, autonomous unmanned ground vehicles. so that those vehicles which can serve I mean, earlier the vehicles can only, robotized EV vehicles can only serve the indoor warehouse. Now, more than an indoor warehouse, it is going to be down highways alongside of conventional passenger vehicles and the uh, the ground mines and the quarries with minimal human interventions, harvesting crops and mowing our lands also. There is too many EV vehicles attached with the robotized system. It is going to be come to the market very soon. So apart from the UGVEC and there is a unmanned aerial vehicle system, those things also come to the market and it is going to be rule the sky. So unmanned aerial vehicles, which is mostly used for delivering the medical needs at the remote areas and also providing the internet facilities to the remote areas. So if we saw particularly the EV vehicles and the robotics, so the both are in the same kind of growth. So so many companies and so many the hobbyists, they are into the development of so many robotized vehicles. So and if we saw particularly about growth of robotics, even from the government of Tamilnadu, we came up with a project called Atal Innovation Mission. That there is a government is funding to the schools. Even from the school students, they are into the robotics, they are into the research of electronics related things. They are developing a lot of vehicles also. So that they learn about the robotics, aero modeling, 3D printing, drones. So when a 6th standard guy know about the robotics, the 6th standard guy know about the electric vehicles, the 6th standard guy know about the batteries and the other electronics gadgets. So obviously when he comes to a 12th standard, within a 4 to 6 years, he can able to develop or come up with a highly innovative product in our country. So within coming next year, he can come up with a beautiful product to the market directly. So he can be an entrepreneur, right? So that the growth of the entire robotics market, so it is the worldwide, even in India also, it is a huge opportunity. So even we can, as per the strategy, we can say within the next 10 years, 120 billion US dollars is the market value of robots and the EV vehicles. So EV vehicles, it is not only for roads and not only for the bikes, cars and autos, it is going to be make a huge impact even in the air. So very soon, I think Elon Musk and the Tesla company, they announced that the electric aeroplane also going to be launched very soon. So that so definitely it is going to be a very bigger impact and the robotized and the collaboration of robots and the electric vehicles, which is going to be give a bigger market. So the company Zappy Robots and MAuto and the other vehicle companies and their collaborations, which can able to create a bigger impact and which can able to create a lot of opportunities in the field of robots and other things. So so thank you so much for inviting me as one of a speaker here. And in the way of robotized and electric vehicles, I would like to thank MAuto Electric and Tatti, so everyone. So thank you so much.
A couple of quick questions to you, sir.
Yes.
How important is going to be the role of automatic driverless vehicles in electric vehicle?
Yes. So so controlling diesel or fuel-based other vehicles. So the handling and controlling systemizing the electric vehicles is much easier. Okay, so the driverless vehicle, that is going to be a future. So so we have, and not only in our country, there is a lot of countries, they are into the research of driverless vehicle, and very soon, we are also into the driverless vehicle. We are very soon come to the market with the automized driverless autos very soon. So that obviously, as everyone said, that is make a very big impact, and that is going to be the future soon.
Thank you very much for your valuable time, sir. On behalf of our institution and all the participants, we graciously accept that for your valuable time during this program, sir. Thank you very much, sir.
Thank you so much.
It now gives me immense pleasure to introduce to all of you the next speaker of today, Dinesh Natarajan. He is a power electronics graduate from SSN in Chennai. He possesses experience in developing power converters for novel renewable applications and commercial units. targeted towards energy generation and conservation while serving as a senior project officer at IIT Madras. As a CTO of a startup, was leading the team to develop indigenous motors, motor drives, and localized controllers for HVAC applications, and was awarded the National Entrepreneurship Award on the Engineering Services category for the year 2016. It gives us great pleasure to have you with us, sir. The session is yours.
Yeah, hi. Hope everything is audible and loud and clear there.
Yes.
Yes. Yeah, so over here I'm here to give a brief about what all the contributions that power electronics will be doing in electric vehicle scenario. So coming to that, what all the other things what I'm going to address is about motor drives, special machines, motion control, and battery management. So I'll deeply dive into each of these subtopics and give an idea about how are these things coming up together to make an electric vehicle possible in this scenario. So before going into that, I would like to address the participants over here. Like the opportunity presently, what India is seeing is tremendous because COVID. I would say it's a blessing in disguise, and all the people who are there to waiting to create an impact or waiting to prove themselves out. All the startups or even the tech enthusiasts who can contribute something to this new upcoming technology can work on this particular lines and do something productive in this particular type. So this particular session will address only about the electric vehicles with respect to the power electronics. So starting with a motor, starting with motor drives. So motor drives, I would say I'm touching upon the micro mobility kind of a motor drive over here. Which would be in the range of like up to a kilowatt or a fraction of kilowatt. This will be targeted to all the micromobility such as electric cycles, tricycles, auto rickshaws, and anything within a limit of the city. So these kind of micromobilities are huge in demand because when you see if you make a bus, it can carry 70 passengers, but if you develop a micro mobility, you can sell in huge numbers where every people will be using it to commute in a daily basis. So these motor drives can be ranged up to a kilowatt of power, and it can be a various form factors. So one you are seeing in this picture are specifically designed to host inside an electric cycle. So the size of it is very much small and compact. So as you see on the bottom of the slide, the PCB is placed on a trackpad, which is you can guess the size out of it. So these are the motor drives presently which are into the picture, and this can be easily scaled up to a fraction of kilowatt, which can be powering an electric tricycle or electric auto, and so on. So mostly the micro mobility sector is going to expand. The bubble is going to expand as faster as possible and as bigger as possible, but the contributors towards that are very minimal. So if you find a competition, there is a healthy competition, but the number of players in this micro mobility sector are very huge, and but the impact is picking up the pace and making it slow and steady. So the electric cycle applications, what I have posted over here is for localized mobility, that means micro mobility again. So these cycles can cater up to 20-30 kilometers of range when you use a direct throttle mode, and you can see about 70 kilometers or 60 kilometers in range when you go for a pedal assist mode. So the pedal assist mode, I mean, you have to pedal it out to exert power and extract power from the cycle. So these are few arenas where.
Sorry to interrupt. Sir, your line is breaking, sir. So sorry to interrupt. Your line is breaking.
Yeah,
if
sure.
possible, please check your net connectivity, sir.
Yeah, just a minute. So is it audible?
Yes, sir. Now it's audible, sir.
Yeah. So okay. Yeah, sorry about that. So this electric cycle over here, which is presented, this can cater up to somewhere around 70, 75 kilometers or 60 kilometers, depending upon the gradients and the place where you are running, and with a pedal assist, that would I would mean. So the drives, which are the main engine of driving these electric vehicles, are getting more attraction, because as you know, the imports of drives from the other countries has been seeing a hard time, and there is a void space which is emerged in this particular drive or electric vehicle scenarios. So most of the people are trying to make or develop their own drives, and um, so that the import is cut down. So one of the drive which we were developing during this season was a 250 watt or 500 watt BLDC motor drive, which can cater up to exert up to 750 watts of peak power and suitable to drive electric three-wheelers also. So these drives were tested, and it has been performing. So this is one of the example or easiest solution which we can afford for a micro mobility. So this is the simplest of the solution, and after this, if at all any more integrations are required, like you need some other torque sensors capability, some other GPS enabled capability, programming over there, and other data logging facilities and display clusters. So whatnot, anything can be integrated to this. So these are the particular drives which are targeted and which are coming into the market to fill up the gaps which are made by the import deficit. So these import deficits are providing us an opportunity. So it is up to us to convert that opportunity so that we can make a fortune out of it. So coming up to the special machines. So the special machines, I would mean, what are the motors which is sufficient enough or comfortable enough to drive an electric vehicle. So you would be knowing BLDC motors, PMSM motors, and the other thing is called as switched reluctance motors. So BLDC motors are hugely in the market because of because of the low cost and easy availability from other countries, and it has been dumped in huge volumes. But when compared to a quality, when we talk about the quality and the performance, it is not performing as expected, because those are made for economically viable solution rather than performing class vehicles. So the next best thing to compare to is PMSM motors, permanent magnet synchronous motors, which are best in class, and it can prove you that BLDC motors are weaker in performance, and it can if you have two motors and make the comparison, you can definitely find that PMSM motors are will perform better when compared to that. So again, one other situation has raised because of this pandemic, because these motors are based out of permanent magnets, which is again an imported material. We don't have the raw material to fabricate it. So this gives rise an opportunity for the machine designers to come up with a new solution where they can provide you with a motor without a magnet. Again, you can say that the induction motor is a non-magnet motor, but the control of an induction motor and efficiency is not so good. So they are going into some other kind of motors called as switched reluctance motors, which can give you the performance closer to this PMSM motor or a BLDC motor. But again, there are critical requirements for it, and the requirements are being bridged, or the gaps are being filled at a faster pace, because more number of people have started working on it, because they have realized imports of magnets and self-reliance will be the key words which will be taken up for the near future. So the magnetless motors are coming into the picture, and one other major requirement of these magnetless motors are it requires tremendous algorithm efforts, because those things will have more code to be done or algorithms to be developed so that the motor receives a better class performance when compared to this PMSM motors. So yeah, so these three motors are ruling the electric vehicle space, but India has a plenty of resource for ferrite magnets, and with that in place, people are trying to work on one other type of motor called as synchronous reluctance motor, which is very close to PMSM motor, but the magnets are replaced with ferrite magnets, because ferrite magnets, when compared with NDFEB or high power magnets, rare earth magnets, these are 4 times lower in power, so that the only thing what is going to change is your volume. So when your volume is changing, your raw materials will be high and your production cost will be high. So the people are working on tackling it out. And most of the BLDC fans, this is again an allied topic. So BLDC fans and other commercial applications are seeing this motor coming up. So they are using ferrite magnets, even though despite they have a deficit of space, they are trying to use homegrown materials and locally available materials to use it. Yeah, so these are the motors which we have developed with some other companies over here. Yeah, so you can see the 15 kilowatt motor, and to the top. So that is a 15 kilowatt motor being tested, and the bottom one is 2048 volt hubless motor, which will be catering for micro mobility application. So as I was mentioning, this 15 kilowatt motor is targeted towards electric three-wheelers or performance class electric bikes, which will require a huge torque, say 20 newtons, and it has to have a speed or acceleration of 0 to 60 in 5 seconds or 6 seconds. So this is what the motor looks like. So this is again has to be optimized. This has been an R&D effort which is put by some other company. So I'm associated with it, and they have been developing the motors since last 6-7 months. So you can have a look at the motor specifications over here, and to the left you can find how it is getting assembled and how the motors looks like, the interior, the stator, and the rotors. So this is again NDFEB magnet based PMSM motor. So the only drawback what we can see over here, or we should focus over here, is importing of magnets. Other than magnets, everything can be manufactured inside in-house, and we can successfully make a motor which can compete with other performance class vehicles, and we can deliver the same effort. So leaving alone the motor and the drive, the next thing to touch upon will be the motion control. So over here, the motion control, I would say the different type of algorithms which will be used to drive the motor. See, when you compare, there are if you see electric vehicles, there are a lot of electric vehicles. You can say an e-cycle is an electric vehicle, an e-rickshaw is an electric vehicle, electric auto is an electric vehicle, and whatnot, even the electric car. But all the electric vehicles may not require the same kind of motion control algorithms because of cost, or because of riding comfort, or because of the necessity which the vehicle demands. So over the top, you can find a 15 kilowatt motor being run on a trapezoidal waveform. This is one other kind of motion control algorithm, which is the simplest of it. And on the bottom, you can find a sinusoidal algorithm which runs a smaller motor over there. So these kind of algorithms will be demanding when you scale up your product, or you want to extract the maximum out of your product. So in that case, you will find a lot of deficits or demerits from trapezoidal waveforms, and the sinusoidal waveforms are much better. So again, there are certain requirements or certain considerations what you can give it to it. Suppose you are designing a motor or a drive for a 250 watt electric cycle, or a 250 watt electric rickshaw or something. So in that case, sinusoidal commutation will not be giving you much of a benefit when you compare to a 15 kilowatt motor running on a sinusoidal control algorithm. So this decisions has to be made by the designer, and he has to decide which control algorithm will be suited for what applications. So you can one other great example I would like to show over here is the trapezoidal algorithm waveform and the sinusoidal algorithm waveform. So these will be giving you much of a problem when you run for a higher load, because you can see a lot of voltage spikes in trapezoidal kind of algorithm, which is not seen in a sinusoidal algorithm. So when you have a high power motor, these voltages will be spiked out, and you will definitely have some negative adverse effect on your windings, on your motor drives, on your power switches, and whatnot. So depending upon the power ratio, you will have to select your switching algorithms, and you will have to cater that particular algorithm to your requirement. So one other thing to mention over here is field-oriented control, which is again a very sophisticated algorithm which will be catered to a performance class vehicles. It can have a torque control for easy starting, smooth riding, and easy braking applications. And the three things what I mentioned in the top is trapezoidal, sinusoidal, and FOC are drive algorithms, and the methods of braking can be brutally classified into two, right? Active and regenerative braking. If you leave alone the mechanical braking system for a electric vehicle, so it can be actively braked using control algorithms again. And regenerative braking is a braking method where you can use the same algorithm to put back the power which can be generated by the motor during the braking into the battery again, so that your range is getting extended at least by 15% or 10%. So this is what these terminologies mean. So I would like to touch upon the scenarios and opportunities over here at the moment. So what scenario is presently being visualized or being seen is there are a lot of opportunities on the micro mobility scale. So micro mobility in the sense the vehicles which can move around within 100 kilometers, like cycles, bikes, mid-range cars, or two-seater cars, or two-seater vehicles which can be autos or something. So these micro mobilities are will be an easy approach for tech enthusiasts, for startups, or mid-range companies or tier 2 companies, so that these can be easily homegrown, leaving alone the electric cars, which will require much of an investment. But these kind of micro mobilities can be easily targeted, and solutions, best world-class solutions can be provided to these kind of applications. So this is the present scenario what we are seeing over here, being in the field. And the opportunities over here, I would like to mention there are humongous opportunities present, which is oriented towards electric vehicle scenarios. So on the top, I have mentioned the few of the products which can be made in-house or made in India, so that we'll again cut down the imports, or we'll avoid depending upon other countries for this simple product. And to the bottom, I have mentioned all the services which can be provided to electric vehicle manufacturing companies. So maybe I'll touch upon a couple of examples over here. So any displays what we are trying to build for electric vehicles are based out of import. So we have to depend upon import for these display clusters, even a pedal assist sensors or torque sensors for electric cycles or electric rickshaws, and whatnot. So these things can be homegrown, and we can make a product out of it. Any startup can easily work on these particular sensors. And the other opportunities is service based, where I can touch upon design services or test facility, creation of test facility, because when you have something developed, you have to properly test it. And to test it, you have to have a knowledge of complete design, so that you have to test it so ruggedly so that the device is not going to fail in the field. So these kind of test facilities and test institutions or organizations can be framed or formed by company or a cluster of people, even organizations. And other thing is service and repair. So when electronics come into picture, we are deprived of technical expertise or technical experienced person or trained person to service or repair these boards. So an organization can be formed, and people can come up, even engineering graduates with electronics enthusiasm and knowledge on electronics can form a test and service center and teach people on that particular training of basics on electric vehicles, how to service a PCB and things. Because now onwards, whatever the motor you will have, you will find a controller with it, and the controller has to be serviced, and the service person has to have some good amount of knowledge, so that the controller can be reused after servicing, rather than throwing out and filling up or ending up at landfills. So yeah, see, these are the opportunities I have put down over here. Maybe they can be still humongous opportunities over here. Whatever I felt which is relevant to electric vehicles funds and other parts. So what we can see is the micro mobilities, which is within the 100 kilometers, where you are using the electric vehicles to move to your office, to move to your shopping place, come back, use within your vicinity, like 50, 60 kilometers, not even that. So you'll not be traveling daily with that particular range. So once you have it, there is a lot of opportunity, because instead of using your bike, you can use your electric cycle. So that's one opportunity what we can see. And once you talk about the job opportunities, there are plenty coming up, because everybody is trying to make or indigenously develop their own controllers. We have seen humongous inquiries coming up to other companies which are dealing with it, because everybody is reluctant to import, or even they presently continue to import. They are always having a side track to develop their own products or their own electronics to sustain themselves in the market in the longer run, because they are not going to trust the import markets anymore, and they are trying to build their own.
Sir, thank you very much for your valuable time. On behalf of our institutions and all the participants, I would like to thank you for spending your time with us this evening, sir. Thank you very much, sir.
Thank you very much.
It now gives me immense pleasure to introduce today the next speaker of the day, Les Mood. He is the founder of Energy Independence Group. He has graduated in Bachelor's of Business in Finance. He is the CFO and COO in Energy Independence Group, Commercial Development Manager at Pure Energy Solar. He's a solar design consultant in Akina Solar, a loan analyst in Mid-State Development Corporation, research analyst at US Department of Commerce. He's written many articles, electrifying everything that will be useful. Sustainability is an idea which has come time at the tipping point. Access to energy and information with microgrid technology worldwide. With this, it gives me immense pleasure to have you with us, sir. The session is yours.
Thank you. Can you hear it?
Yes.
Okay, great. Then I will share my screen here. Can see my screen now?
Not yet, sir.
Got it. Okay, great. Okay, well, you guys can see this, yes? Okay. So, yeah, I want to talk, so we have about 15 minutes or 12 minutes or so.
You can go on, sir. No problem, sir. You have at least a half an hour ahead. No problem.
Okay, great. So, yeah, I want to talk about the future of energy in India. We've learned a lot. We've learned a lot in the United States over the years, developing solar projects, energy projects in general. We're a little ahead in terms of the amount of time and the lessons learned. And we also have our own challenges. I actually am lucky to be on the computer here. The power was not on. So in California, we're having these power shutoffs. And even if you have solar power, your power may not be on because you don't have the batteries, you don't have a microgrid. And that's a situation I'm in. I've got solar now in this house that we recently moved into. We put solar on, but I haven't got my batteries yet. So I am was without power throughout the night. So that's why microgrid technology will be useful. One of the reasons, but other reasons would be that there may not even be power lines where you want to have the power. So this is a photo of a project from 10 or 12 years ago, maybe more, that I did. It's mounted on the ground, and the reason I showed this picture is because this is really the old way to do solar. You have the solar system here, but above you have these power lines. This is a grid-tied solar system. It's not able to run when the power goes down, because it relies on the grid. So for safety reasons, solar shuts off, as many would know, when the grid shuts down, unless you have what's called an automatic transfer switch. And so this is really a first generation solar system. And you know, what we're looking at now, where the real market movement is happening, where there's a big need, is with distributed energy, distributed energy over long distances is what we have here. These power lines, and that's part of the net metering. Well, what happens if you don't have power lines? What do you do? And obviously, you know, not every part of the world has power lines. Certainly not every part of India, and there's parts of California, even nearby my house here, that don't have power lines. And so it's very expensive if you do want to bring power lines, if that is an option, but it's not always an option, and it's certainly not an economic option in many cases. So that's where wireless energy comes in, wireless without being connected to the utility grid, and doing it locally, using it locally, producing it locally, and using it locally is, in my view, the most efficient way for solar power to be produced and used is locally. If you were to compare from some of the leaders that are in the industry, that your power generation from the point of production to the point of use may be as much as a 30 to 60% loss of power across the power lines. So in order to transmit electricity over long distances, you're really losing a lot of that power. Whereas if you're using it locally, you're not. So there's a major cost to distributed energy, and there's a major loss to distributed energy. You're spending a lot of money for the power lines, and if you're using it at the end use, if you're a business, you're manufacturing electric vehicles, or you're just a homeowner at home, the majority of the cost is the transmission, not the production. So on one hand, you know, coal and nuclear and these and even large-scale solar projects are very cheap, but that doesn't really matter when you have to spend a ton of money transmitting it. So transmission of power is very expensive and inefficient. And we have seen the cost of solar and energy storage come down so significantly that you'll likely still be able to produce power with the additional equipment cost of energy storage for less than what you would otherwise spend with the power to be transmitted. And so so we live in an age now where wireless energy can be produced locally and used locally. This is a photo of a project that one of my first carports. I like carports when it comes to solar. You know, it's to me more about a philosophy than it is about technology or who the manufacturer is or any of that. Our philosophy is simply energy independence. So if you're an American, in this case, it's red, white, and blue. You know, everybody in America, for the most part, likes their independence, and India is very similar in its pride for entrepreneurial spirit and the idea of self-reliance. And so independence in general, I think, is an opportunity, a mindset that would work really well for India, especially when you develop the power that you need further and further for your country. So I see a big parallel between the American entrepreneurial spirit, which really is just an entrepreneurial spirit that anyone anywhere in the world has. There's a lot of people who come to America because of their entrepreneurial spirit, but it's exciting to see in India that a lot of activity is happening, particularly in electric vehicles, as well as solar power, and you have a strong drive right now, I can see, to produce as much of your technology in the country as possible. So I see, and I am excited by this spirit that you have in India. So what really is an opportunity is the solar microgrids with energy storage, energy management, and electric vehicles. I believe that if you're going to develop the solar market and the electric vehicle market at the same time, you might as well integrate the electric vehicle into the development of the solar market. And the way to do that would be to have a solar microgrid with the transfer switch a control system that manages your appliances. So maybe it turns things on and off just so that you don't you're not using too much power at any given moment. So you have advanced energy management software, algorithms running on a panel, for instance, that controls the energy coming in and the energy going out. So a microgrid is just an energy control system that isolates and islands itself from a grid if you are tied to the grid, and if you're not tied to the grid, it can run independently. And so, you know, I believe that if you look at the cost of the batteries, that it may be prohibitive to do a large enough battery on a property, say for a home. You know, so some of those solutions are on a community basis. If this is a community of several hundred houses right here, everyone could actually have their own solar system, but they don't necessarily need their own battery if everyone's homes are tied together. And that's a lot easier to achieve than running major transmission lines across a country or across a community. So in this case, a small neighborhood, you could have all of these solar systems tied together and then use one battery. That's an option. But as well, an option is to plug in your electric car and to use the electric car as the battery source. Now, there are some efficiency issues, the round trip efficiency of charging and discharging an electric car. So you'll lose some power going in and you'll lose some power going out. But when you consider that the alternative is a battery by itself that doesn't also serve the purpose as a car, or when you consider that you don't have the option of power otherwise, or when you consider that power has to be transmitted from long distances and there's losses already, then in my view, the losses are worthwhile in many situations to see the round trip efficiency losses from the electric vehicle. In India, I believe, are justified. That being said, there is opportunity for car manufacturers, battery operator, or the batteries inside the electric vehicles to have newer technology. And so I would encourage anyone interested in applying newer technology to the electric vehicle to essentially make it a power plant where it can roll around and discharge energy itself without necessarily a charging station. This is a concept that some companies have, but that the technology doesn't currently is not on the market for. So there's a person that I would have liked to join us, and maybe he can join next time. But there's a company that in the United States was funded to do research on a new type of power electronics. And I'm in an NDA, so I can't say too much, but what I can say is that it's the best technology in the world, and it would be available to any car manufacturer who wishes to use it. So if any of you are involved in car manufacture, or you'd like to experiment with making the electric car a power plant that can roll around in power buildings or be used for vehicle to grid technology, vehicle to home, vehicle to business, I believe 160 or 166 kilowatt charger can be built into the car. So you don't need a charging station. You don't need to build out the major infrastructure if you have a car with the charging station already built into it. It doesn't need to be expensive. It doesn't need to be highly, it actually can be cost effective. And so that's something that, since the last time I spoke with people from India on this presentation several times, that technology I was not aware of, and since I've been approached. And so that's an option. So anybody listening, if you want to message me about the possibility, if you're working on electric cars, to try out new technology, I would love it. But basically, the Department of Energy funded research, and the Department of Energy for the United States government funded research which which will be capable of doing what I just described. But in the United States, there's a lot of red tape. There's a lot of bureaucracy. There's a lot of existing business models that would be broken if this were deployed. So the reason I'm excited to talk with people from India is that you don't have the hurdles to overcome. You don't have the red tape. You've got the entrepreneurial spirit, and you've got the opportunity, and as well as the need to develop new technology that would allow there to be no power lines. And so this is the technology, and it's the technology I've been waiting for. But basically, when you combine technology, you can accomplish more. You can do more with each piece. And so in this case, here's, you know, solar power, wind, and a car. Well, if you just have the solar and you just have the wind, you need power lines. But if you have the solar, you have the wind, and you have the car, you don't. So technology is stronger together. And you know, the friends that have this technology I mentioned are, and the company is Seinwatts. They believe in maximizing the use of individual things. So your car or your home or your business might as well do more than one thing. So if you treat the car as not just a car, but also an energy storage facility and a power plant, you're getting a lot more value out of the car. And I believe that due to the cost of these cars and this technology and everything, that normally when you think of one aspect of the technology, you're limited. I mean, you may not be able to justify it financially, but when you accomplish more than one goal and you kill two birds with one stone, then it can be justified financially. So I see a huge opportunity for India to leapfrog the need for power lines, for you know, transmission lines, by maximizing the use of an electric car. So otherwise, if you don't use the electric car as a battery, you'll buy a smaller battery for more money than you would to already have had the car with the battery inside of it. Now, you may not have the car at home all the time. You may not, you know, utilize the car all the time. But it is certainly an option, and it would reduce the overall size of the solar system that you would need, or the battery that you would need. So anyway, it's a huge opportunity, mostly to advance the deployment of electric vehicles. The more you can do with the electric vehicle, the better. And when we're talking about vehicle-to-grid technology, part of the reason that it hasn't really happened is because of the round trip efficiency and the losses associated with charging the car and discharging the car. This new technology, these new power electronics from America don't require or don't lose all that energy. So you can charge and discharge on a regular basis and really efficiently use the energy, which has never been done before. So I'm telling you about something that is going to revolutionize electric vehicles, but that is hard to accomplish in the United States because there's just not the kind of activity that's happening in the United States as there is in India on a development basis. Most of the electric car manufacturers in the US are big OEMs that have either acquired some other company or they're working with another company. They're very hard to get a hold of. So if we can work with new OEMs in India, then we can help India leapfrog, not just needing power lines and transmission lines, but also advance the most technologically capable electric vehicles in the world. So that's honestly why I'm excited to share this idea, is because along with the idea comes opportunity for anyone that's interested in discussing how to integrate these power electronics into the electric car to make it a lot more useful. And so, but that's basically the idea that I have is, wireless energy using electric cars. And electric cars one day may be autonomous. So you could have electric cars driving around that have nobody inside of them, or just power plants. You click your phone or your phone automatically tells the car to come because you need more power. So power can be delivered now using cars and or vans or trucks. And so this new wireless electricity is a huge opportunity to avoid major infrastructure costs. But as well, what's really neat about it is the electric car can pay for everything. Instead of having transmission lines here, a car there, a battery here, a solar system there, you have everything utilized most efficiently in one package. And that requires the right technology and the right philosophy. And in this case, that's the direction that we're going. And I see the biggest opportunity is for India with the technical skills to build everything. So what I would recommend is that, India continues to move in the direction that it is, where it's building and making and having the training and the technical understanding about the electronics in India. But essentially we could assist the deployment of this new technology that would for the most part be built in India using the US government funded technology, which is a unique opportunity. And the reason I would bring it to India would be because I see the difference that it could make is much greater there, as well as the resistance to the disruptive innovation that would occur that would essentially completely turn the business model of the utility markets, the oil markets, everything would be turned on its head. Whereas in India, that wouldn't be a problem because there is not so much infrastructure to put people out of business. But if you really think about it, I'd appreciate you guys to think about the impact of power plants rolling around and what that would do for your country. And then anyone interested, reach out. We're on LinkedIn. So I'm on LinkedIn. Please find me on LinkedIn and let's connect. I'm Les Mood. And then hot energy news every day, Monday through Friday. We're covering 5 stories that are the hottest stories in the world related to energy. We talk about electric vehicles. We talk about solar power. We talk about microgrids, wind energy, geothermal, any type of energy, hydropower, pump storage. So all of these developments that are happening on a daily basis are covered on Hot Energy News. And so we try to stay on top of the latest developments and share that with the world. I encourage you to please find us on social media. We're on Facebook, LinkedIn, YouTube, and Twitter. If you search for Energy Independence Group, that's our company. We cover the hot energy news. So if you're looking for us, search for Energy Independence Group, but definitely where I'm most active and easiest to reach is on LinkedIn. And that's where, as a professional platform, you don't have to see all the crazy people that are talking about weird things, commenting weird things. It's more professional on LinkedIn. So I do prefer LinkedIn. So if you want to connect, I'd encourage you to connect again, for information on hot energy news and to collaborate possibly. And then if any of you, I would please encourage you, if any of you know or may be involved in electric vehicle battery development, we'd like to discuss applying these new power electronics to bidirectional power electronics to the battery so that it can charge and discharge in a highly efficient way and essentially be a power plant. And that's what I am very excited about. I hope that there's some people here that are also involved in the electric vehicle battery development, and we can talk about how to.
Yes, a couple of quick questions for you, sir, from our participants. First one is, how e-vehicle is eco-friendly?
How are electric vehicles eco-friendly?
Yeah.
Yeah, so electric vehicles are mostly made with lithium batteries, which require, mining of cobalt, nickel, and lithium. So they don't exactly start out being the most friendly in that way. And they do need, the batteries will eventually need to be recycled. And the good news is there are companies that are recycling lithium batteries now. So if the batteries are recycled, then you could say that there was little environmental impact. But yeah, you'll see a lot cleaner air in your communities, a lot less noise pollution. So if say, in one of the bigger crowded cities where you have a lot of motorbikes, if you could electrify your motorbikes, imagine how much quieter it would be. And motorbikes seem to have the most pollution, much like lawnmowers and weed eaters. So those smaller engines pollute more than the bigger ones. So, but yeah, the electric vehicles will reduce your overall air pollution in your cities, smog, and that the impact that has on health will be minimized. As well, some people are concerned about the amount of carbon in the air. Decarbonization is possible with electric vehicles. So if global warming is real or not, it won't really matter. But if it is real, this will help. And if it's not real, at least, we help with some of the air pollution in the cities, in the smog. Since the lockdown happened in California, we live in a valley, and all the pollution from Los Angeles and San Francisco, it comes into our valley because it's lower. Well, since the lockdown, our air has been a lot cleaner. So that would be a good example of what would happen if more and more people were driving electric vehicles. The issue in the United States is that electric vehicles, the more that happen, our grid isn't going to be able to handle it. And it's already driving up demand for electricity dramatically as the market shifts to electric vehicles. The opportunity in India is you would want to deploy solar at the same time as your electric vehicle. And if your solar and your electric vehicle are working together as a microgrid, you can justify, you can more easily accomplish doing solar by having the electric car. So if you don't have a utility grid running to your house, what are you going to do? You need batteries and you need solar panels. Well, if you can avoid that battery cost because your electric car is serving that purpose, now it makes solar more affordable, and the solar makes the electric vehicle more affordable. But as far as the environment goes, it would be good to air quality, mostly on a community basis. That would be the most immediate effect you could see, is cleaner air for your community.
So one more question to you, sir. What are the different type of e-vehicle batteries and recharge methods which are efficient, according to you?
So what are the different types of batteries and recharge methods?
Yeah, which is efficient, according to you?
I'm personally not the power electronics engineer, but the main batteries that are being used are lithium. There are some nickel batteries being used. There's different types of lithium. As far as the battery type goes, to me, that doesn't matter as much as the power electronics that convert it. You'll find whatever batteries you use, if they're saying 48 volts, can be used with the Scienwad's power electronics. And the key is to convert and to move the energy bidirectionally in the most efficient way. So when the energy goes into the battery through the power electronic, you don't want to lose power. And when the energy comes out of the battery through the power electronics, you want to maximize. You don't want to lose that either. So my view, the most revolutionary aspect of the electric vehicle's capabilities is the power conversion, not the power storage. So we can take any battery stack or set and apply these inverters to them to essentially be able to operate a lot more efficiently. So normally an electric car, so the different types of charging methods, normally you pull up to a charging station and you have level 1, 2, or 3 charging. And so level 1 is the slowest, level 3 is the fastest, level 2 is in the middle. So, but normally you have to pull up to a charging station and you have to find one. And that's what the problem is also in the United States, is what comes first, the chicken or the egg. Tesla built a bunch of charging stations because they were smart. So they did that at the same time they sold their cars. But one of the problems with deploying electric cars is going to be, where are the charging stations at? So when it comes to deploying solar, electric vehicles, you have 3 major challenges. 1, to put in the solar. 2, to put in batteries. And 3, where are you going to charge your car? All 3 of those would be solved by building the charging station inside of the car. And it would be it would automatically be part of the car. So instead of needing a standard worldwide plug, and they keep changing, the standards are changing, who knows what the standards will be in the future. Instead of that, imagine you could just plug your car in with the normal plug, a heavy duty plug, and you could charge a building. So you pull up to the grocery store and you say, you know what, I'm going to sell my electricity to the grocery store while I'm sitting here because I have some extra power. And then the car would automatically track through blockchain, through artificial intelligence, blockchain, a system that would know exactly how much energy you're putting into the building and all of that kind of stuff. So any participant in the marketplace would be able to utilize this peer-to-peer network. So basically each car could be a power plant with a peer-to-peer blockchain network, to where if you're charging your car somewhere, you get billed for it from the supplier of the energy. If you're powering a building with your car, then you can charge for that. So it's all you know, it's a series of technologies combined into one would be an electric car, energy storage, vehicle to grid, and a peer-to-peer energy network that would allow you with your car to be a power plant. And if you had an autonomous car, your car could roll around and make you money while you're sleeping, maybe. So there's a lot of possibilities, but the main thing is the power electronics, the bidirectional inverter is really going to allow the greatest potential for the car to serve far more than just one purpose of driving you around. So we want to maximize the use of the car to make it part of the electrical infrastructure.
Sir, on behalf of our institutions and all the participants here, we would like to thank you for spending your valuable time with us and sharing your thoughtful inputs and about the futuristic prospects of e-vehicles. Thank you very much, sir. Smart people learn from everything and everyone. Average people learn from their experiences. We have given you a lot of inputs about e-vehicles. Hope it was useful to all of you. With that, we come to a close of day 2. Let us all rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
To all the participants, a sincere request to you, kindly fill up the feedback form. Your feedback form means a lot to us. Even yesterday, many people had asked questions. And also what you can do is, you can also send us a mail about all the questions you would like to ask to the speakers as well. So tomorrow we'll be having a virtual tour of how EVs are manufactured. We are going to share with you how electric autos, electric bikes are manufactured. We are going to have a virtual tour about inside the industry, inside the workshop, how it is being really manufactured. So do join us for yet another day tomorrow evening same time. We are also I'll also share you the Facebook link wherein you can watch every day's program. So in case if you have missed out on something, let us say you have joined a bit late, or maybe you have missed out on some day, maybe you have missed out on next day, you can watch it on Facebook. The video will be there. You can watch it on Facebook as well. We will share you the FB link in the chat box. You can watch it whenever you're free and share it with other people. So once again, please fill in the feedback forms and join us tomorrow for yet another day to learn about e-vehicles. Have a wonderful evening and a wonderful weekend ahead. Thank you all.